Hello and welcome to today's ACM Learning webinar, Preventing Information Leaks with Policy-Agnostic Programming, with speaker Gene Yang and moderator James Mickens. This webcast is part of ACM's commitment to lifelong learning and serving the over 93,000 computing professionals and students who are ACM's members. I'm Jan Timonovsky, ACM Education and Professional Development Manager. For those of you who may be unfamiliar with ACM or what it has to offer, ACM offers educational and professional development resources that bolster skills and enhance career opportunities. Our members can stay competitive in a constantly changing world of computing with a range of ACM Learning Center resources at learning.acm.org. You can see some of the highlights on your screen right now. ACM recognizes the role of computing in driving the innovations that sustain competitiveness in a global environment. It provides timely computing information published by ACM, including communications of the ACM and Q magazines, access to ACM Digital Library, the world's most comprehensive database of computing literature, international conferences that draw leading experts in a broad spectrum of computing topics, as well as support for education and research, including curriculum development, teacher training, the ACM Turing and the ACM Prize in Computing Awards, as well as many others. ACM enables its members to solve critical problems using new technology that enriches our lives and advances our society in the digital age. Before we get started, I'd like to quickly mention a few housekeeping items shown on the slide in front of you. First, the slides will advance automatically throughout the event. On the bottom panel, you'll find a number of additional widgets and resources. If you are experiencing problems with the slides or audio, press the F5 key in Windows, Command R if you're on a Mac, or refresh your browser on a mobile device. Or you can close and relaunch the presentation. To control volume, adjust the master volume on your computer. If you have questions during the webinar, and we hope you do, please type them into the Q&A box at any time during the talk and click the Submit button. Gene Yang and James Mickens will organize the questions during the recorded presentation, and they'll reserve plenty of time in the second half of the hour to address them. This session is being recorded and will be archived. You will receive an automatic email notification when it becomes available. And check learning.acm.org for updates on this and other upcoming webcasts. At the end of the presentation, you'll see a survey open up on your screen. Please take a minute to fill it out to help us improve our webinars. You may also open the survey at any time throughout the presentations from the menu dock at the bottom of your screen. You can also use the Facebook and Twitter widgets on the bottom panel to share the presentation link with your friends, as well as tweet comments and questions using the hashtag ACMLearning. We'll be watching for your tweets. We also have a new community discourse page to continue the discussion both during and after this webcast, including questions we won't be able to get through during the Q&A session. You should be seeing a window open up in a new tab of your browser in just a few moments. You can bookmark it and return to it after the presentation if you wish. You can also click the discourse link in the resources window on your screen at any time. And now, without further ado, today's featured presentation, Preventing Information Leaks with Policy-Agnostic Programming by Gene Yang and James Mickens.
All right, yeah, we are now on the air, live. Are you ready? You've been training for this your entire life. Hi, my name is James Mickens. I'm the host of everybody's favorite game show, Who Wants to Be a Personal Assistant to an Eccentric Billionaire? That's right, it's the only TV show that gives you, the American public, the opportunity to help an awkward rich person continue to be awkward and rich. That's John Bustamante III, worth over $97 billion. He hasn't purchased his own shoes since the late 1970s. Let's try to keep it that way and get this guy a personal assistant. Here's today's contestant. Her name is Gene Yang. She's from someplace in Middle America. I'm sure it's lovely there. Some fun facts about Gene. She is 7 feet 6 inches tall. She wrote all of the lyrics for Beyonce's I Am Sasha Fierce album. Also, Jean Yang has a capybara named Xander. A capybara, it's like a small land manatee from South America.
Basically, none of that is true. I'm a computer science professor from Carnegie Mellon University who focuses on programming languages. In particular, I study programming models that make it harder for programmers to leak secret data.
Yep, that's pretty much what I said, so let's start the interview. And by the way, I apologize that we're conducting this interview over a satellite phone made of 1980 cell phone connections. Even eccentric billionaires have a hard time with video conferencing. Anywho, what kind of experiences do you have with eccentric billionaires? Have you ever watched someone burn a pile of money and then had that person ask you to take them to McDonald's to buy them 18 large fries and a small milkshake? Then they just dump that milkshake on the ground because they're rich? Have you ever done that?
No, I generally don't go to McDonald's, but I do think that I'd be a great assistant for an eccentric billionaire. Eccentric billionaires have a lot of secrets, and I am very good at keeping secrets from leaking. For example, take John Bustamante III.
John Bustamante III has no secrets.
Did you know that he's a furry?
Are you a Jedi? Where did you get that picture? Security, there's a Jedi in here. Code red, send everyone.
I'm not a Jedi. I found that picture on his Twitter account.
That's impossible because Bustamante doesn't use his real name on his Twitter account.
But I was able to discover Bustamante's account because of information leaks. Here's what I did. I found a tweet about John Bustamante's son, Trevor Fitzgerald Montgomery Bustamante. The tweet about John's son had a link to an Instagram post. In the Instagram post, there was a mention of the son's Instagram account. Now, the rumors are true. Trevor Fitzgerald Montgomery Bustamante is no fool. Trevor knows that his dad is a famous guy, so Trevor made the Instagram account private. However, there are information leaks from private accounts on Instagram. In particular, when I tried to follow Trevor's account, the follow request was denied. But Instagram helpfully gave a list of recommendations for other people I should follow. This list included a bunch of people from the Bustamante family who all use their real names on both Instagram and Twitter. The list of recommended people also included a certain Samwise Bigfoot. As it turns out, Samwise Bigfoot only followed Bustamante family members on Instagram. As it turns out, Samwise Bigfoot's Twitter profile was only a few months old. As it turns out, John Bustamante, patriarch of the Bustamante clan, had recently made a public statement which said that he only recently got on Twitter and he only follows his family members on Instagram. And thus, John Bustamante's Twitter handle was revealed. Let me also say that this kind of unmasking was exactly what happened to FBI Director James Comey. A journalist named Ashley Feinberg was able to unearth Comey's private Twitter handle using the exact same process I had just described.
Newsflash, eccentric billionaire John Bustamante is James Comey. I can't believe it. I've been working with John for 7 years. You think that you know someone, but they hide things from you. I just want to be loved for who I am. Do you see what I'm saying?
No.
Just a little? Do you kind of maybe see what I'm saying?
No.
Okay, this is a very awkward episode of Who Wants to Be a Personal Assistant to an Eccentric Billionaire. Anyways, let's move forward. You were describing how information about John Bustamante could leak via social media platforms like Instagram. But as the old saying goes, leak my furry photos once, shame on me. Leak my furry photos twice, shame on you.
That's not actually a saying.
This article on InfoWars begs to differ. Regardless, why can't Instagram just get rid of those information leaks? I mean, Instagram hires a bunch of smart people. Why can't the programmers just fix the problem?
Well, the problem isn't figuring out how to fix the problem. Applications like Instagram generally do a fine job of protecting information that belongs to individual profiles. Things get messy, however, when applications have interfaces that span multiple profiles. For example, what happens when the application wants to suggest new friends for you to follow or new bands for you to listen to based on what your friends are listening to? What happens when an application like Instagram wants to let you search the entire universe of profiles for people who live in a certain city or have a certain interest? It's very difficult to prevent information leaks across all these recommendation algorithms and search interfaces.
Right, because of the Higgs boson. It's like being in a snowstorm where the snowflakes give you mass.
Right. Maybe what you meant to say is that it's difficult to prevent information leaks because of all the cut points where programmers have to write security checks. For example, think about a large-scale web service that contains a bunch of databases and web servers and has a bunch of complicated application logic that runs on a bunch of different machines. To prevent an information leak, you can't just look at what information is leaving the database. You also need to look at where the information is going and whether it interacts with secrets before it gets there. For example, consider our poor friend, Mr. Bustamante. Both his profile photo and username are actually public information, but the leak happened because this was shown based on private information, specifically who Trevor Bustamante was following. Figuring out where to check and what check to put depends on reasoning across the entire program.
Okay. You can see that information leaks are a big problem. But guess what? I read the technology section of a little paper called the New York Times. I've read about this thing called encryption.
Do you mean encryption?
I mean, you know what? So I could check to see if you knew how it was pronounced. But anyway, using this encryption, we can just scramble all of Bustamante's data before we upload it to the cloud. And in this way, nobody can tell what Bustamante may or may not be doing. I mean, he's not doing what you think that he's doing, but so just there's nothing to see here. It's the power of encryption.
You're right that encryption is helpful in some cases. In particular, encryption is good for providing coarse-grained, context-insensitive secrecy. For example, think about the Sony data breach or the Target data breach. In both cases, the companies were storing sensitive user data in clear text form. So when attackers broke into the servers, they immediately got access to raw user information. If Sony or Target had encrypted the data, then the encrypted data would have been useless to the attacker. However, encryption has some big gaps. First of all, standard encryption schemes like RSA and AES do a poor job of expressing the conditions under which clear text data should be revealed. In traditional encryption schemes, if you have the right key, you always get access to the data. But what if a Facebook user only wants to expose your location data to the daily list of allowed stalker friends and only at certain times of day? Encryption doesn't help with managing this. This is connected to the problem that key management is hard for users too. Users have to keep track of all their keys. How are they going to do that? The reason about cryptography is probably a bad idea. I mean, people can't even pick good passwords. Let me guess. Your password is football.
Nope, not even close.
Is it Jesus football?
That may arguably be closer or warmer, but I have no specific comment about that.
That's my point. If people can't pick good passwords, it's hard to believe that they can successfully manage a bunch of keys to encrypt all their online data.
Okay, fine. I understand why encryption can't stop 100% of information leaks. But what about differential privacy? According to a Wikipedia article whose accuracy is disputed, differential privacy is equivalent in power to a 50 gigahertz RSA key.
Yeah, that's pretty big. Not quite. Differential privacy restricts how much information you can learn about a specific piece of data in the system, but not quite equivalent. Think about Spotify, the music streaming service. Spotify probably keeps track of a database of which users are listening to which songs, and that's how they let us see results of general queries like how many people have listened to Justin Bieber this week. So now let's say you and I are the only users of Spotify. Then if that's the case, I see one user has been listening to Justin Bieber, and I can figure out that it's you. You've been listening to Justin Bieber this week. If there are a lot of users, this kind of query won't reveal whether you in particular have listened to Justin Bieber, because then you're just one of millions. Differential privacy uses math to quantify when these kinds of aggregate queries are allowed to prevent leaks of sensitive information.
Just to be clear, public service announcement, James Mickens has not been listening to Justin Bieber, but have you seen his recent concert poster? Dreamy.
Don't worry, James. Your secret is safe with me, and I'm sure everybody else watching right now. But the important thing about differential privacy is that differential privacy doesn't work for many kinds of services. It's designed for queries with an explicit and quantifiable trade-off between accuracy and privacy. You can make something more private by making it less accurate. For instance, saying that 18.6 million users listen to Justin isn't so different from saying 18.7. It doesn't, however, make sense to build a partially accurate social networking app in which you comment on your friend's post and then some inaccurate version of the comment is shown to the users, or the comment is probabilistically shown or not. How followed users should show up to a recommendation algorithm has the same problem.
Okay, so what I'm hearing is that there's no way to build applications which prevent data leaks. Do you want to be the one who tells that to Mr. Bustamante? I don't know if you've ever delivered bad news to an eccentric billionaire, but they tend to throw things.
That's true. Well, I mean, I personally can help Mr. Bustamante. That's why I'm on the show. I can help him by preventing data leaks because I know all the ways data can leak and I can stop it. But there's hope for everybody else too. In my research, I've been working on a programming model that's explicitly aware of information flow and makes the machine responsible for protecting secret data.
Why should I have to learn a special programming language? I'm already fluent in HTML.
HTML is not a programming language, so you might not want to put it on your resume.
Yeah, open bold tag, string, I don't care what you say, HTML is a programming language, close bold tag, booyah, you've just been HTML.
Awesome. I look forward to the day when I too can successfully complete the first 20 seconds of a Khan Academy video. Anyway, the reason we need a new programming model is that regular programming languages don't provide a way for developers to reason about data flows or user privacy.
Hashtag false. Isn't there a lot of work on programming languages that explicitly support information flow control?
Hashtag true. You're correct that there's been a lot of prior work on information flow control, or IFC. This work allows programmers to explicitly tag values with whether a given viewer, called a principal, is allowed to see them. Code acts on behalf of principals. A program can act on Alice's behalf, and then it can't read a value that may only be read by Bob. You can detect these information leaks at compile time before the program runs, or at runtime by tracking labeled values through the program. In both cases, the programmer has to write the program more or less correctly because these information flow control techniques can only stop the program.
That sounds great. So what it sounds like has happened is that the problem of information leaks has already been solved. So it's time to go home, folks. Strong work. High fives, everyone. Not you, Stephen. Everyone knows that you have mono. So please just seal yourself in a human-sized fish tank.
Stephen doesn't have mono. He's just quiet.
Why don't you go shake his hand then?
I don't shake hands with quiet people. Anyway, there's a problem with traditional IFC approaches. They ignore the importance of context. For example, IFC systems are good for expressing policies like only expose Mr. Bustamante's location to a restricted set of people, and then they'll stop the program before it leaks Mr. Bustamante's location to everyone. But consider what if we wanted to express a policy like expose a fuzzy version of Mr. Bustamante's location to his coworkers, but expose the precise version to his doctor. In this case, the identity of the viewer should define how the application exposes the data and not just whether the application exposes the data. There's another problem with traditional IFC approaches. I call this problem leaky enforcement. Leaky enforcement happens when a program fails to correctly handle dependencies between policies on sensitive values. For example, suppose that we want to build an online service that allows an organization to run an award ceremony. We want the service to enforce two properties. First, only people who have won awards should be able to see the list of awardees. Otherwise, people might get jealous or something. Second, the list of awardees should be kept secret until the list is finalized to allow the awards committee to play around with potential awardees before they make some final decisions. So how do we determine whether a person should be able to see the list of awardees? We have to make two checks, whether the person is in the awardee list and whether the list has been finalized. Programmers have to explicitly remember to perform both checks when showing the list of awardees. Otherwise, horrible tragedies could ensue. For example, let's say the second check, whether the list has been finalized, is missing. then someone who was in a non-final list might look at the list of awardees, see his or her name, and then show up at the award show, even though their name is not in the finalized list of awards. Leaky enforcement can happen whenever programmers are required to manually implement a bunch of interweaving policies that depend on each other, as happens when you have to encode all your policies in terms of labels. I've talked with people in industry, and they've all said this is definitely a problem in practice as well.
I've got a bunch of industry friends too. They give me frisbees and mouse pads and tell me that my internship application was strong, but there were a lot of qualified applicants, so I should maybe try again next year.
We have to fight the darkness. As it turns out, we can dramatically reduce the cognitive burden of developers who need to prevent information leaks. We can do this by using programming models that separate out the definition of information flow policies from the definition of the rest of program control flow. For example, let's go back to the example of Mr. Bustamante's location. In a traditional programming language, we might define the following function to release his location. As you can see, it's pretty easy for the developer to forget to fuzz the data or check for a particular type of viewer. In the new model that I propose, policies are defined as standalone values, and a developer focuses on writing the correct functionality, while the programming language, the runtime, and the compiler becomes responsible for enforcing the policies. So the developer can write what's called policy-agnostic code that looks like this. The very exciting thing is that there's no policy enforcement at all. The developer does not need to specify different versions called facets or a sensitive data value. They can just define a value like this. And then the language runtime and also the compiler can determine which facet of the data to reveal at a particular sync. And now the programmer can use this location in all sorts of computations, for instance, showing Mr. Bustamante's Facebook profile, graph search over who are all the people being treated for halitosis right now, who are all the people in New York right now, how many people are patients at this medical center, etc. And all the programmer needs to do is define these values, define the policies, and then make sure that effectful computations are saying the right viewer who's seeing the values. Now, the language runtime and compiler are responsible for determining which facet of user location should be exposed in different viewer contexts. And we've also built a web framework on top of this where the framework keeps track of the viewer and the programmer just needs to attach policies directly to data schemas.
But how exactly does the programming model determine which facet to expose? I mean, what foul stratagem or witchcraft have you brought into this fair land? I cast you out, demon. I cast you out.
As it turns out, witchcraft isn't necessary to determine which facet to expose. At a high level, you just have to fork a new copy of the program whenever the execution path manipulates a faceted variable. You create a new copy for each faceted result. For instance, if I want to know how many people are being treated in this halitosis medical center, there's one copy of the program for the actual location and one copy of the program for the city. Later, when the program executes a viewer-dependent operation, the runtime determines which universe contains the appropriate facet to reveal and reviews that one.
Awesome. So running an exponential number of program copies sounds super efficient. So is the name of your programming model massive computational overhead? Or maybe it's called, I don't know, a 96-core machine struggles to run a faceted version of Hello World?
Well, James, we have to think outside of the box here.
But I like the box. The box smells like cinnamon.
While you were inside the box, trying to become one with the spice, my research group discovered something interesting about faceted programs. It's true that a large number of program copies are necessary to formally describe the correctness properties of faceted execution. However, from a practical perspective, multi-execution, this simultaneous simulation of different program paths, is frequently unnecessary to actually run a faceted program. The reason is that if we know where the value is going to go, we can just throw away all the other facets. And often, For instance, in a web framework, we know where that value is going to go. It's to the session user. And it turns out that we can also achieve an approximation of the multi-execution semantic by rewriting the program at compile time. We've been working on a static approach that will figure out where to insert conditional permissions checks into your program before it runs, so we know whether the program is allowed to use a sensitive value for the given viewer or it should use a default alternative value instead. Programmers express these checks as fancy types called refinement types. Refinement types are fancy because they can depend on program values. For instance, you can say that an integer x is allowed to exist if it's greater than 0, or if the viewer is Alice. The compiler then has to prove this property in order for the program to run. Our system uses type error localization to figure out where checks need to go, and then synthesizes the appropriate check from the type. Quite magical, if you ask me.
So witchcraft is involved, just as I suspected. Look, Mr. Bustamante is a temperate man who normally does not tolerate the supernatural, the arcane, the eldritch, or the Lovecraftian. Now, he might make an exception in this case, but how do your fancy types stop leaky enforcement?
Well, the nice thing about these policy-agnostic systems is that they manage all the policy relationships for you with respect to the program. And we have a guarantee of non-interference and also policy compliance according to a detailed formal semantics that we've expressed. And so to explain what our security guarantee is, let's return to the example of a program that manages award ceremonies. We enforce a version of standard non-interference that takes into account this additional fact that policies might themselves depend on sensitive values. The standard non-interference guarantee in information flow is that if a viewer isn't allowed to see a secret value, then the secret value could be anything, and that shouldn't affect the output. In our case, secret values can influence whether a viewer is allowed to see secret values. For instance, consider the policy that you have to be an awardee to see the secret list of awardees. So we have to think of this space of secret awardees in two parts. Viewing of the secret value, if the viewer is in the list of awardees, and those that don't, if the viewer is not in the list. The space of those that don't should be indistinguishable. If you aren't allowed to see the secret awardee list, then the list can contain Bustamante or Comey or Justin Bieber, but you shouldn't be able to tell.
Okay, this all sounds fine, but we know that programmers are lazy. They don't want to write test cases, they don't want to write comments in their code, so I'm guessing that a lot of programmers will not want to write policies. So what happens then? We can't just go to the policy tree and wait for a policy acorn to fall to the ground and then try to shove that acorn in our program. It's been known for years that acorns do not belong in computers.
Policies do need to come from somewhere. Fortunately, some of my current research is about exploring how we can retrofit existing programs to a policy-agnostic model. For example, I'm looking at automated techniques for extracting policies from regular programs and for propagating these policies. Once the policies have been extracted, we can then add enforcement using a combination of the static and dynamic approaches that I've been talking about.
Well said. And on that note, let's conclude this very special episode of Who Wants to Be a Personal Assistant to an Eccentric Billionaire? Today, we've experienced the gamut of human emotions. We've laughed, we've cried, we've learned about the tragic intersection of dandruff, halitosis, and refinement types. And, oh my goodness, we've got a very special someone approaching the set. It's none other than Mr. John Bustamante himself. Come on down. Mr. Bustamante, what do you think about policy-agnostic programming models? Sometimes I pour the tea with the crumpet at £2, 6p. The tardigrade can survive in space. Paddington, Time Lord.
You weren't kidding about the eccentric part.
Acorns inside the computers make them safer. So true, Mr. Bustamante. So true.
Wow.
My hand looks like an spider. Monsters aren't real, Gene. What do you think?
I'm going to do that part over. Well, you're in
nice box. Like YOLO. It's like the most awkward form of mansplaining. Christmas time is here. La, 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 la. I basically have perfect pitch.
Okay, so we are now live. Thanks to everyone for listening, and we are now ready to take some questions. Jean, are you there?
Yes, I am.
Excellent. Okay, so one question that I want to ask is, can you describe your prototype implementation for policy-agnostic programming? So what exactly have you built, and how did you build it?
This is a good question. So we started out with a prototype implementation as an embedded domain-specific language in Scala. So essentially a Scala library where we overload the operators, and we have a special way of calling functions, doing conditionals, etc., so that you're doing faceted execution in Scala. The implementation that we've been working with most recently is in Python, where we do dynamic source transformation of the Python code, and with a combination of overloading. And we use that to build a web framework called Jacqueline on top of the Django web framework. So you can now build web apps in a policy-agnostic way. And then finally, we have a static type-driven approach for policy-agnostic programming that we've been implementing in Haskell, well, specifically Liquid Haskell, which is Haskell with refinement types. And we've been building a version of the Yesod web framework that's using policy-agnostic programming for Liquid Haskell. And so the idea for that is eventually you should just be able to write policies in a very central place alongside your data schemas, and then the type checker will propagate your policies, rewrite your program so that everything gets enforced.
I see. So can you talk a little bit about how this policy-agnostic framework is or is not compatible with non-managed languages?
Yeah, so that's a very good question too. So one way that we've been interfacing with non-managed languages is by implementing our faceted execution or policy-agnostic programming approach as a library that has the ability to rewrite code. Because what happens is, in order to do this, you need to be able to compute on these faceted values at every point potentially. So you need to overload your arithmetic operators, your Boolean operators. You need for conditionals to be able to condition on potentially faceted things. Your function calls need to be able to handle the fact that you're calling a function on potentially one thing or another. And so if you have a language that lets you hook in that way, then that's the easiest way to use it. The way that we've been interacting with SQL, actually, though, is through an object relational mapping. So normally, if you have a web framework or something like that, you interact with SQL databases through some kind of library that manages a uniform object representation between the application and the database. And here we just additionally manage different potential views of your data across the application and database. And if you're interacting with SQL only through our ORM, then you have all the guarantees of actually using the language itself.
Okay. Very nice. So we have a question here from David. And so David's question is, he wants to know about how you do debugging and testing. So what he's asking about is, let's say that you've defined some policy-agnostic code, and there's a particular set of variables, and they all have these different facets they can assume. So let's say that somehow the developer picks the wrong type of policy or the wrong type of facets for this data. How can you debug a program that is using a bunch of these faceted values in ways that may be buggy and may cause weird cascading problems as the program executes?
Yeah, that's an excellent question. We've developed many debugging strategies as we've been working with this model. Yeah, as with everything, there's a set of best practices that develop. One way to start is to just make sure that when you're accessing a value directly, it's showing you the right version of the value. when you expect it to, and then going from there, building that into bigger and bigger pieces of functionality and seeing that, okay, hey, actually, yeah, this is interacting with the code in a way that we expect. But something interesting that we've observed is sometimes the policies we write interact with the code in very strange ways. And so when we look at it, just the one value, it does something, but then we do something else, and then policies get resolved in a different way. And it turns out that this happens when there's a dependence of policies on the code itself, which is something that often happens in real life. So, if you're on Facebook, you have to be a member of the secret guest list to see it. You can see James's location if you're within 50 feet of it. Like, that's computed by the code. And so sometimes when you have these dependencies, really weird things happen. And the nice thing about using this kind of model is you can reason about what's happening in terms of, well, I wrote down the policy I intended, and this is what the language is supposed to do to it. And so you can kind of think about, okay, these are the only places where I could have done something wrong. How this relates to the phenomenon of people having these dependencies in already in languages that people are currently using is that these kinds of bugs often arise in practice when people are building applications like Facebook as well. But it's often harder to pinpoint where the bugs might be. You just have these weird interdependencies, and you're like, oh my God, where is it the policy? Is it the code? Is it some weird other interaction?
So have you found it difficult to reason about multi-execution in practice? I mean, if you set a breakpoint, are the semantics of setting a breakpoint something like I'm setting a breakpoint in 15 simultaneously executing quantum worlds? How do developers think about such a thing?
Yeah, so that is an open area of research. In fact, there are a couple of people at CMU, Christian Kastner's group, and there's a couple of people at University of Maryland who are looking at how do you want to visualize these kinds of programs if you're executing multiple possible worlds. So yeah, we don't have an answer to that yet, but people are looking at this.
Okay, cool. Here's another question, this time from John, and so the question is, how does your programming model handle sensitive values in collections? So in other words, let's say that you have a list or something like this, and the list has objects which have different policies or different faceting strategies associated with them. How does code interact with data structures like this?
Yeah, that's a good question. So it's really up to the programmer, because you can put anything in a faceted value. So you can put your whole set or your whole collection in a faceted value, in which case the whole thing has the same policy. But one property of computing on these faceted values is all values computed from a faceted value become faceted with the same policy. So you could have a whole collection that has a policy that says only James can see this collection. If you get one element from it, that's also a faceted value that says only James can see this collection. Alternatively, you could have a collection with individually faceted values, and then when you take them out, the individual facets will have their policies associated with them. You could also have a faceted collection with faceted values inside, which means that the policies just get layered on top of each other.
Okay, that makes sense. Another question came from Carl. So Carl's question is, this sounds like aspect-oriented programming. So can you comment a little bit on the relationship between aspect-oriented programming and this policy-agnostic framework that you've created?
Yeah, that's a question that we've gotten a lot, and it's a very good question. And it alludes to one of the reasons we did this work. So I was very fascinated by aspect-oriented programming because I hated writing boilerplate code. And so I would always think about, okay, what's something that I'm doing in code over and over again, and how can I make it go away? And it seems like, well, for aspect-oriented programming, that's the solution. But there are limitations to aspect-oriented programming as is. And the biggest one is that it's a framework that sits on top of existing mainstream programming paradigms. And so because it does that, you can only hook into the program at specific join points. And so it turns out aspect-oriented programming is super good for things like printing log statements or other kinds of things having to do with debugging. But if you want to do something that's closely intertwined with control flow and actually potentially changes control flow, as we want to do with the case of information flow policies, if you remember in the Bustamante example, you have this situation where you want to make sure that John Bustamante's photo and username aren't getting leaked, even though that itself is public, but it's being computed based on a secret value. So those kinds of things are really not possible to do with a framework that can only let you hook in at specific points. And so there were aspect-oriented solutions that would do things like take the whole stack and try to capture your history by walking the stack, but it was still pretty limited in what it was able to do. And so if you want to do something like change the way your program behaves based on information flow, you really have to hook into your program semantics. You want to hook in at every conditional, every function call, etc.
I see. Okay. So here's a question that's come up in a couple of different listeners' questions, is this notion of databases and persistent storage in general. So if you look at these large-scale web services, which you might think would be amenable to some type of policy-agnostic coding, they have to store data somewhere. And presumably these policies need to somehow be aware of database schemas or how data is sort of being read or written from the storage backend. So could you speak a little bit about that?
Yeah, great question. So that's something we discovered when we started trying to build web applications using this model. We had a Scala implementation at the time, and my advisor said, oh, go build a website based on it. And, you know, I wasn't really building that many websites. I was a PhD student in computer science. But the first thing I realized was, oh, crap, all websites interact with a persistence store. And the minute we do anything interesting with a database that's not just loading all the data into memory and using our runtime, we're subverting all of our guarantees. And so I spent a couple of years working with some people to extend our guarantees to database-backed applications that work with standard SQL databases. So it was really important for me to be able to have this work with a standard SQL database and not some kind of special faceted database, because I think the likelihood that anyone's going to ever use a faceted database is very low. And so our solution consists of wrapping around SQL in a way that extends our semantics. So the faceted values have two components that corresponds to two rows in SQL. And then we store metadata that keeps track of which facet we're currently storing in that row. And then it turns out that you can actually use existing SQL queries for select, join, order by, and some other things. And the only things that you really can't handle using SQL doing this kind of representation is aggregation functions, which we're currently thinking of other strategies for. But what we showed essentially is that you can extend the faceted execution runtime model across to a SQL database if you can carefully store metadata and have your object relational mapping manipulate that data carefully, which is very exciting for us.
I see. So do you have a sort of back-of-the-envelope calculation or estimate for how much slower the database becomes, or what's the storage overhead in terms of keeping track of these policies for each one of these items?
Yeah. So naive storage overhead is 2x for every value, or if you have a tree of facets, it can blow up more. But right now in the static solution, we're looking at not storing the extra values in the database and just having the compiler insert the right value to return when you're retrieving things from the database, if that makes sense. So your storage overhead doesn't have to be super high, because if all you're doing is returning default values from the database, you can make that interaction smarter so that it's only when your alternate other value you want to show is somehow dependent not just on your current secret value, but like other things you need to store in the database that you have additional overhead. But in that case, it's not really our programming model that's giving you that overhead. You would have had to store that information anyway.
Right.
Yeah, so what we found was that in terms of querying the database, there wasn't a super high amount of overhead. It was in the overheads come from reassembling the faceted values from the database after you get the data back. And those can get pretty high. What we found was that most of the time what you can do is you can throw away your extra facets pretty much immediately, because like if you're in a web framework, you have a session user, most of the time your value is going to your session user. And so with this kind of throwing away optimization, which we call early pruning, your overheads are 1.5x max. But I think that this is a reason we're currently looking at static solutions, because then you don't have any additional overhead beyond what the programmer would have to write in terms of checks anyway.
Mm-hmm. Mm-hmm. That makes sense. Another question about applying these techniques to real-world systems. In a distributed system, have you thought about how policies might have to be propagated across machines? I mean, a database is just one example of, sort of like an external entity that it would be useful to be able to reason about policies. But, let's say I've got, some 18 gazillion tier web service where I want policies to flow between those different machines. Can you speak a little bit about the challenges in implementing such a scheme?
Right, yeah. So one of the motivations for the way we designed how our policies worked is to allow a decentralized policy management model. So each faceted value is associated with a label, and then different entities can make the policies on that label increasingly restrictive. And so this is conducive to a distributed policy management scheme. And so you can imagine a situation where people are passing around labeled faceted values, and maybe you consult a central policy store where everyone has to tell their policies to you about what the strongest policies on the label should be. But yeah, so also we made some other choices, like policies are increasingly restrictive, so that it would make sense in a situation where many potential agents were contributing their policies.
Right. A related question that I just thought of, and also apparently one of the listeners that David thought of, was, is it ever necessary to make the policies themselves sort of secret or obfuscated in some way? In other words, is it possible for a policy itself to be a sensitive value that might need to be faceted or otherwise, protected from, I don't know, reflection or things like this?
Yeah, so that's a great question. Definitely, the case that we've really been considering a lot is when policies can contain sensitive values. And so the bit about leaky enforcement, I don't know if David got that, was about that case where if your policy can depend on a sensitive value, a mistake that often happens in practice where all policy enforcement is trusted and not really checked is that enforcing a policy can leak information about other sensitive values. And so definitely policies can contain faceted values. The policy itself right now can be one big faceted value. And so, yeah, that's definitely a way to obfuscate the policy, though we haven't thought about that case as much as we've thought about the other case.
I see. Okay, that makes sense. And can you talk a little bit more specifically about the way that developers should reason about policies as they're trying to create policies for their applications? I mean, at a high level, if we look at these traditional approaches for IFC, the labeling-based approaches, then one of the knocks has always been, it's complicated. It's hard for humans to sit around and think about label lattices and things like that. So can you describe the thought process that a developer should have when they're trying to create one of these policies? And this kind of relates, I guess, to the testing and debugging question too.
Right. So one motivation for us designing a higher level language than labels for policies is because it's really hard to encode a policy like only my allowed stalkers can see my location if it's Tuesday or Thursday after 5 p.m. There's a lot of room to get that wrong because, it's like, okay, well, for Alice, what's her label? For Bob, what's his label? For Carol, what's her label? Like you have to get all those cases right. And so in the current policy models we've been looking at, the policies are functions that take a viewer and return a Boolean value true or false. So they can be things like if the viewer is a member of the secret guest list, then the policy function returns true, and that implies that the viewer is allowed to see some value. And the body of the policies can refer to any of the program state. So that's how we capture dependencies of policies on sensitive values. We're looking into a couple of other directions right now. One is actually getting some of these policies from the code, or at least checking these policies against things programmers might have already written in the code. And so sometimes if you're building an application, it's more natural just to write conditionals in the code some places where you want to check something. So one thing we're looking at right now is how can we propagate these checks to combine with policies to make sure that your policies are what you expected them to be. Something else is we're thinking about what would higher level policy languages look like to give you a more restricted language, but more ease of reasoning about the space of possible policy outcomes.
Okay, that makes sense. Some people have been asking about the relationship between policy-agnostic code and facets and encryption. And I think some of these questions are relating to this idea of, well, we can define these policies and define these facets that allow us to sort of control the aspects of data that's being released. But is that related in any way to, let's say, having to encrypt, let's say, some facet of a variable as it goes out over the network, for example, or as it lives in memory? So can you comment on that?
Yeah, so the relationship between facets and encryption is something that I've talked to many people who work on encryption about, and there's no concrete work on combining it, but one direction is, definitely you can think of like one possible use for facets is you use them for different levels of encrypted data. And then people can try to decrypt as they're allowed. Another way that we've talked about combining facets with encryption that I'm not sure if this addresses part of this question, but I think is interesting, is with encryption, there's the problem of key management. And so one way that we've talked about addressing the key management problem is to use faceted execution, use this policy-agnostic programming with faceted execution to resolve who should get what key. And then you can figure out, then you can have this guarantee that the right people can decrypt.
Great. Let's see, a question here from Walter. Walter asks about the relationship between policy-agnostic code and proofs or formalism. Do you think that policy-agnostic frameworks might be amenable to leveraging some of this research that's been done recently on these formally verifiable programming frameworks? And once again, I think this kind of gets back to this notion of testing, debugging. How do you know that the policies are actually providing you with the policies you actually want?
Right. Yeah, so there are a couple of levels of answer to this question. So one is how does this relate to the formally verified frameworks? So there has been a lot of work on formally verifying systems for information flow properties, and in fact, this work took inspiration from some of those systems. So around the time I was starting to work on this Jeeves language that I've been developing, I also worked on F-star, which is a refinement type language for distributed security programming. And what they're doing was proving security properties of programs by annotating them and showing that the programs written the way they are preserve the properties that we want. And what I thought to myself was, oh, wow, it's really hard to write programs correctly. Wouldn't it be nice if there were a way to make these programs have these properties by construction? And so the property that we're going after with these policy-agnostic programs is very similar to what you would want to formally verify a system for. But what we are verifying is that every program that runs on our system has this property, rather than specific programs in our system have this property. But but something interesting is that for our static type-driven approach, we actually had to first make a verification system for information flow in order to do the program repair based on this. And something that we're looking at is if you have a system that's trying to formally verify your program for these properties, how can it interact with a runtime that does these properties for you by construction? And so we're looking at, okay, what would the invariance be that would be of the code coming out of this kind of runtime, so that we could prove other properties against that.
Right. Nice. Okay. I think that that makes sense. One question, or that's sort of, I guess, several questions that have come up, and we've touched on this a little bit with prior discussions we've had, but some people are asking, for example, can you implement policy-agnostic frameworks in a language like C++, for example? You know, we discussed a little bit about this notion that it's not just managed runtime languages that are amenable to this technique, but can you speak, is there anything sort of specific about C++, for example, that might make this technique a little bit tricky to implement, or something like Java or C#? Because I think that there is a possibly erroneous perception out there that, you know, if we're working in sort of these very academic languages like Haskell, then it's easier to do some of these tricks, you know, with the special PL support. But if we go to quote unquote more you know, engineering focused, more practitioner oriented languages like C++ or Java or something like that, these things become trickier. So can you speak to that a little bit?
Yeah, that's a great question. In fact, it's some of the things I'm most excited to work on. So one thing I've been realizing as I've been working on this programming model is that sure, I can develop this nice programming model all I want, but we have all this legacy code that's written in not this way. And until we have a solution that can bridge the way people are currently coding with this new way of coding, it's just not going to work. And so something I've been thinking about is how can we use the policy-agnostic model as a way to help us understand what's going on in legacy programs, and potentially how can we retrofit something like C++ or Java with this kind of model? So I'm really excited about the static type-driven repair approach because it starts hinting that we can take existing code and rewrite it to insert checks in the right places. And but in order to apply it to something like Java, there's a few more steps, and in order to apply it to something like C++, there's even more steps. Right. So there are techniques that that hint at how we can get there. So right now, the Liquid Haskell is just a great starting point for doing this work because we have this really clean type system. We have the refinement types. We can essentially just use type error localization to figure out where the checks need to go. And so then the next challenge is, okay, we take something like Java. How can we graft this fancier type system onto it so that we can do the same kind of repair? And so there are techniques out there called gradual typing that take a language with fewer types and add more types to it with a combination of static and dynamic analysis. So these kinds of techniques, I think, are super promising for taking something like Java and adapting such a technique. For C, it's going to be harder, right. But it's not super impossible. So Andrew Myers has this work that is typing assembly for information flow, and so I think that if he can type assembly, we can definitely type C++.
That's right. Anything is possible in this world.
Yeah.
Great.
Yeah,
so one final question before we wrap up. Just out of curiosity, have you talked to anybody in industry about the possibility of adopting these policy-agnostic frameworks?
Yeah, so I started talking to people in industry a few years ago, and at that point, they said, yeah, we need things at huge scale. Your thing really doesn't scale right now, et cetera, et cetera. Also, we have other priorities. But recently, I think companies have become more interested in this. Oh, a side note is that I worked at Facebook summer 2013 implementing a back-end privacy tool that was related in terms of policies, but not quite this. And even at that point, I think that just like the place where these companies are at, were not they weren't in a place where they're really they could really afford the slowdowns of introducing some kind of heavyweight tool to plug into their system, and also they didn't seem to want to spend the engineering effort to like completely rethink the way they did privacy. But in the last couple of years, I've really noticed a big change. I think people have started realizing, oh, wow, we have lots of policies. They're really complicated. People actually care, et cetera. The place that people seem to care the most is in healthcare and managing health data, because you actually have HIPAA on your back if you don't manage that correctly. So that's been the place where we're currently starting some active collaborations with industry. I think that in terms of commercial software, there's not quite the regulatory threat, and so I think people are less willing to take on something completely new and crazy. But I think that in a few years we'll get there.
Sounds good. All right. Well, unfortunately, we've run out of time. People ask so many questions. Our conversation has sparked so many dreams. That's why we do these webinars. Anyways, thanks everyone for listening. Don't forget that if you go to the discourses page, which should have opened in tab earlier, you can continue the discussion. Thanks to everyone who listened today. This webinar was recorded. It will be available online in a few days at webinar.acm.org. And you can find announcements on upcoming webinars and other HCM activities at learning.acm.org and also at acm.org. There's a lot of acm.org URLs that you should check out. Also, please fill out the quick survey, which was pushed out earlier and should be in a separate tab on your screen. And on that survey, you can suggest future topics, future speakers. If you think that Gene and I should be nominated for a Turing Award, please feel free to put that nomination there. We will thank you in our acceptance speech. So on behalf of ACM, Gene Yang and myself, James Mickens, thanks again for joining us, and I hope that you will join us again in the future. This concludes the webinar.
Thanks, James.
Thanks, Gene.